Okay, so here are two questions that we could ask when it comes to functions. And I drew these diagrams, and you could use these diagrams here to help explain each of your answers. So the first question is what is the relationship between A and the image, the pre-image of the image of A, right? That's what this is saying, okay? We need to know that this F inverse notation means the pre-image, right? And F of A is the image of A. We need to have good definitions and understand those definitions. They are in the book, okay? These definitions, all right? So now the image of A under F, that's this. That's F A, like that. This is the image of A under F. What that is it's all the elements in the codomain that are sent from A. So it's really, let's give a definition to this. I wish I had my book. This is a on the spot definition. Don't kill me. It's all the X in the codomain of F such that or all the Y, let's say Y in the codomain of F such that there is some X in A, right? Such that there is some X in A with F of X equal to Y. And that's the definition of the image of A under F. So basically, like, if you have it, like, a good example to illustrate the relationship between the original A and this set is to think of just if it's a constant function. So everything under F goes to, like, one value, x naught. So then that means that everything in A goes to this one value. Okay, and everything in the entire function goes to this one value. So even points over here are gonna, F is gonna send all of that points to this one value, x naught. Now, what's the image? Well, in this particular case, F of A is just the set containing x naught, right? And then now we have to ask ourselves, what's the pre-image, right, of this? And the pre-image needs definition, right? So what's the pre-image of a set, some set B, right, or whatever? It's gonna be everything. So this is gonna be the set, right? It's everything that gets sent into that set. It's the things, everything that gets sent into it from the domain. So like if it's B, right? What's the definition? This is just the definition. This is as general as I can make it. It's all the X in the domain of F such that F of X equals Y is contained inside B, right? So it's all the X that gets sent into B. So what's the inverse image of this set right here in this case? Well, the inverse image in this case, right? Again, this is the constant, right? So what is this? That's what we're investigating. What is this? In this case, what's the inverse image? The pre-image, sorry. The pre-image is also called the inverse image, but our book and the way it is that we said it in class, it's called the pre-image. What is the pre-image of this 1 point set? Well, everything in the domain gets sent to this image. So it's the entire domain is the pre-image of that one thing. In this case. So in this case, right, what's the relationship between A and this here? Well, it has to be that A is a subset of the pre-image of the image of A, right? Because in this case, in the case of where it's a constant function, right, we have it where this relationship will hold. And you don't know what F is. F is any function. So it must be that this is the relationship between these two. Now, the next one, we want to play a similar game. We want to sit here and figure it out. I don't even know what the relationship is. I sit here and I figure it out, whatever. Because I draw these pictures. So now, in this case, it's saying that we have B, some subset in the codomain of F. What is the relationship between B and the pre-image? And this is the typo. The typo was on the review, but I switched it. So that was the typo. Thank you. Anyways, so now this here, yeah, it's the pre-image of B, the image of that. So the image of the pre-image of B. So again, what is the pre-image of B? It's this definition here. Whoa. It's this definition that we have here. Okay. So what is it in this case? Well, I don't know. Let's try and make it so that way not everything is hit. So how can I illustrate this relationship? Because now I don't want to guess at what the relationship is. So what was it? We needed so that way not everything in B is hit. Let's see, what do we need to happen here? So again, you see I'm figuring this out as it is. So let's say I have, right, so let's say we have these elements inside B, whatever, these green dots, okay? Now the inverse image is going to be this here, right? So that's going to be the inverse image. Now I want to show, right, but not everything in B could be hit, right? So there could be elements over here, right, so that aren't hit, and I'll do an actual example of this, okay, to illustrate how we're going to get this relationship. So all these dots, these purple pinkish dots, and then these dots as well, are all in B, but only some of them will be hit by the function. So there's only going to be a few x over here, whatever, x1, x2, x3, that actually hit some of B, but not all of B. So the image is now, this here is, let's say, F inverse, the pre-image of B. And then the image of that is just these points here, just these 3 points here, which is not all of B. So then that means that the relationship is that this is going to be a subset of B. And you could illustrate it with an example, right? So a good hardcore example is going to help you. Okay, so a function could be from any set to any other set. So let's take a set 1, 2, 3. Okay, and then let's take a set, or let's take a larger set, I suppose. 1, 2, 3, 4, 5, right? Okay, and here's my domain, and then here's the codomain: star, circle, square, triangle, right? And then B is some subset in the codomain, right? So B is some subset in the codomain. This is the codomain, this set over here. So in this case, this is the domain, right, over here on this side. And then this is the codomain. Now, what is it that I have here? So now I have some function. So let's draw in a function. Let's say I have my function going like this. And I want to be careful. Oh, wait. B is, let's say B is this subset of the codomain, right? So this is B. Okay? It's a subset of the codomain. And then now let's say that my function looks like this. So 1 goes to star. 4 is going to go to star. 5 is going to go to star, let's say. 2 will go to triangle, whatever. And then 3 will go to square. And this is a well-defined function. Muffin! Okay, now, what do we have here? The inverse image, the pre-image of B. What is that? So, let's go and look inside B. Here's B, right? The inverse, right? What does it go to? It's going to go to 5, right? It's going to go to 4. So this is what I'm investigating, the pre-image of B. It's going to go to 1. And the pre-image of B, F, the pre-image of B is just the set 1, 4, 5. Okay, and we should see that as 1, 4, 5, right? Nothing hits circle. Okay? And then the image, right, of that set, the image, F, the image of this set is going to be everything that this goes back to, which is just star. And that's not all of B. This now equals just the set star. And that's not all of B. This is a subset of the original B that I chose as these 2 elements. And this is a good, you describe this out, or you even write this example and you show me with these diagrams like this, it's perfect. It illustrates that you understand the relationship between these two sets. The difficulty is really just understanding that, this means the image and that this means the pre-image when, this notation is weird, right? That's the ugly thing. This is the same thing as the inverse function. But this has nothing to do with the inverse function. Okay, this is the pre-image. This one is said the pre-image of B. Okay, that's a B. Pre-image of B. Okay, and then this is the image of A. Okay, and I define those roughly in the video. You see this with this here. Oh no, sorry, wait, where is it? This. This is a definition of the image. Okay, but again, it's in your book, and if you don't have your book for whatever reason, then ask someone in the class to take a picture for you and show you the definitions. And also, this is gone over in the book as well, okay? These questions are answered in the book. So, okay, now, yeah, and then this is the pre-image, this definition here. X contained in the domain of f such that f of x equals y that's contained in B. So it has to be that f of x is just contained in B, basically. But yeah, that's the pre-image. And understanding these definitions is tricky. It takes some time, but this question is literally, these questions are literally to have you understand these definitions. That's how these questions were designed. But okay, that's why I put them on the midterm. Okay, so go ahead, try and figure this out. I wish you all the luck.